and percentages. So let's get started with solving ratio problems. So you can see our success criteria there. Okay, we're looking at ratio problems, scaling up or down, and finding equivalent ratios. Now then, as always, the Kahoot challenge is here for you. So go to kahoot.it and enter in that code. Or you can click on the link on the daily task sheet and it will take you straight there. Easy peasy, lemon squeezy. Okay, so when you've had a go at that, come back and watch the rest of this video. Okay then, let's have a little look at our first problem today. So, what is the ratio here? So I've got this rectangle here. What is the ratio from one side to another side? Have a little think. What is the ratio? Well, this side here is 40 centimeters, and this side here is 20 centimeters. So the ratio is 40 to 20. Now I can simplify that down. Okay. Now you may be looking at this and shouting out, going, I know what it is, I know what it is. That is great. Now to simplify a ratio, you would just divide. Like a fraction, whatever you do to one side, you must do to the same to the other side. So if I look at this one here, 40 divided by 20, I can definitely half them both. I can divide them both by 2. So I'll simplify it down and go to 20 to 10. I can simplify that even further. I could go 10 to 5. And I can go even further if you know your times table, and this would actually go to 2 to 1. Okay, so this ratio here to here is 2 to 1. Basically means it is 2 times bigger. Whatever I do to this side, okay, this will be half it. Or whatever I do to this side, then this side will be double. Okay, so the ratio of these sides is 2 to 1. Okay, it's 2 times longer than that right hand side there. Okay then, what would the ratio be here? Have a little think to yourself, what is the ratio here? Of course, if you say 30 to 20, you are absolutely correct. Okay, now again, I can simplify that down. And like a fraction, whatever I do to one side, I must do to the other side. Now let's have a little think about this one. I'm not going to start halving this one. I'm going to go straight away to a very clear one. They are both, okay, multiples of 10, which means I can divide them by 10. So the ratio is 3 to 2. Now I could indeed say, I could halve this and go, well, the ratio is 1.5 to 1. But I often don't use decimal places. However, sometimes you may be asked to. So the ratio here is 1.5 to 1. So for every 1 centimeter here, it would be 1.5 centimeters on the top. Or it is the same plus another half. Okay, so that's me simplifying those ratios. Now then, what is the ratio of stars to circles here? What is the ratio of stars to circles? So, how would I solve this? Very simply, you count the stars and then you count the circles. So the ratio is 1, 2, 3, and 4. So I've got 4 stars. So how many circles? 1, 2, 3, 4, 5, and 6. Okay, so the ratio is 4 to 6. Does it simplify? Are they both divisible by the same number? Of course they are. I can divide them both by 2, therefore leaving me the ratio of 2 to 3. Okay, let's look at the next problem. Okay, we're moving on a little bit here now then. So a box has milk and dark chocolates. The ratio of milk to dark is 3 to 4. There are 21 chocolates altogether in the box. How many are milk chocolate and how many are dark? So I've got my ratio. I know how many are in the box. And the question I've got to work out is how many are milk chocolate and how many are dark chocolate? Well, there's a simple way to solve this one here. I could just write down for every 3 squares, write down milk, and for every 4 squares, write down dark. So let's do that one. Change to a slightly different colour here. Okay, so I've got milk chocolate, milk chocolate, milk chocolate, dark chocolate, dark chocolate, dark chocolate, and dark chocolate. And I will repeat again. Milk chocolate, milk chocolate, milk chocolate, because there's 3 of those. And then there's 4 dark chocolate ones. look again. Let's write down milk and dark again, okay, because I've got my 21 squares here. Milk, chocolate, milk, chocolate, milk, chocolate. There's 3 of them. And then there's another 4 dark chocolates. And there we go. It works out perfectly, okay? So how many milk chocolates do I have in the box? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 9 milk chocolate. And dark chocolate, well, there's 4 on that row, 8, and then 12. So I've got 12 dark chocolate. Okay, and how would I check this? Well, I would add these two together and make sure it equals 21. So I've answered my question. How many chocolates are in the box? There are 9 milk chocolates and there are 12 dark chocolates. Okay. Now let's look at solving this in a slightly different way, because we can't draw boxes out if there was like hundreds or thousands. Okay, I need to use my math skills to help me. So to do this one here, okay, what I would do to find the total of a ratio is I add the ratio together. Okay, so I add the ratio together to start with. I then divide by the total amount of all the parts. So this finds me 1 part. And then I multiply by that 1 part to find out how many total parts I would have. Well, let's look at that in practice if that is a little bit confusing, okay? So, same question, but I'm going to follow these steps through, okay? So, how to find out the total amount of milk chocolates and dark chocolates here. So, I'm going to start by adding the ratio together. So, I've got, the ratio is 3 to 4, so let's add it together. 3 plus 4 is equal to 7. Okay, so that's how many parts I have got. Now then, divide the total amounts by all the parts, okay? So divide this 21, I've got 21 as my total, okay, 21 total. Divided by all the parts, divided by 7, so 21 divided by 7 is 3. So each part, each one of these is equal to 3. I've got 3 parts and I've got 4 parts. So therefore, to find out my milk chocolates, okay, milk is equal to the 3 parts times the 3 that I have, which is equal to 9. And for dark chocolate, then in this case, I'm going to be multiplying 4, because I've got 4, times by my 3 is equal to 12, okay? And that is how I would solve this using my mathematics, especially useful when the numbers are much larger, okay? So there we go. Ratio of 3 to 4, 21 chocolates altogether, add them, then use that number and divide it, well, this number divided by that, and then I multiply by each part that I need to multiply by. So let's have a little look here. Let's do the same sort of thing. A best-selling fruit juice is made from apple juice, raspberry juice, and blackcurrant juice. The ratio of this is 2 to 2 to 1. So there's 2 parts apple juice, 2 parts raspberry juice, and 1 part blackcurrant juice. If 1 litre of juice is made, how many millilitres of each juice are needed? So my first step is to add up my ratio. 2 plus 2 plus 1, well, that is 5. So I've got 5 parts. Okay. How much is each one of those parts worth? Let's go on to that next step. So I take my 1 litre, so 1 litre, but I'm going to change that into millilitres, okay, because it's going to be much easier to divide. So 1,000 millilitres, okay, because it's much easier to divide. So 1,000 divided by 5, okay, 1,000 divided by 5, you'll get 200 millilitres. And now I need to work out how much for each one. So apple juice, I'm going to use A for apple juice. There are 2 parts of that. So 2 times 200 is equal to 400 millilitres. Let's look at raspberry juice next. There are also 2 parts of this. So raspberry, well, it's the same. 2 times 200 is equal to 400. And my final one, blackcurrant juice. So I'm going to use B for this one. There's only 1 part of that. There's only 1 of them. Times by 200, well, that equals 200 millilitres. And if I add them all up, I should get 1,000. 400 plus 400 plus 200 is indeed 1,000 millilitres, which is 1 litre. So how many mils of each juice are needed? I need 400 mils of apple juice, 400 mils of raspberry juice, and 200 mils of blackcurrant juice. So Excellent work, Year 6. You have done really, really well. Okay. And we're now going to move on to our task for today. So, squares, triangles, and circles, your work has already been sent to your parents and it's on Google Drive. Just be careful, there are two different triangles work. Okay, there's triangles 1 and triangles 2. So they would be about what you would be in the classroom with me, okay? Of course, as usual, if you want an extra challenge, you are more than welcome to try another group's work. Answer your questions, and if you would like me to mark it, send me the answers. Otherwise, answers will be sent to you at the end of the day. There are some extension activities with ratios on Study Ladder, so go and have a go at those if you wish. So, Year 6, have a great session. I look forward to speaking to you in a little bit. Goodbye.